All right, we're going to be looking at lessons 67 and 71 kind of together. Lesson 67 is about transformations. And then lesson 71 is a specific transformation, and that's why we're doing them together. So probably the obvious question you're asking yourself is, what are transformations? So let's give ourselves a definition. So transformation is anything that will result in a change in position, or a change in size, or a change in shape. Okay, so a transformation will cause a change in position, size, or shape. So position, it might take a shape and move it somewhere else or something like that, change its position. Change of size, imagine you've got a copy machine and you take a little picture and you put it on there and you blow it up. That transforms its size. Okay, or you could have a shape. So imagine you had like a triangle made out of rubber bands and you could take and stretch part of it. Okay, and you change the shape. Okay, if you left this part of it the same and you stretched the top of it, it would not be the same shape anymore. So in all of those cases, you would be transforming something or changing it. Like transform just means change, right? So we are interested in a certain class of transformations. All transformations, well, their job is to take some shape, which we call the pre-image. Okay, this is the original. And we're going to do some kind of transformation. Okay, and we change it, and the result that we get after we do the transformation is called the image. Okay, so that's what this is the original. This is like the new shape that we get. Okay, so the class of transformations, okay, changes that we can make to go from the pre-image original to the new image called the image, that we want to look at in particular today are a class of transformations called isometries. So an isometry is a special kind of transformation that preserves the shape and size, or the size and shape. So this preserves the size and the shape. So in general, transformations could change position, size, shape, or all three of those. Okay, but the isometry is not going to change the size, and it's not going to change the shape. It's going to preserve those. Okay, so if the original goes through a transformation and it's exactly the same size and exactly the same shape as it was before, they're congruent, right? So these are special because the pre-image will be the same in size and shape, meaning it's congruent to the image. Okay, so that is what is special about an isometry. Okay, and so you've probably talked about these isometries before when you were a kid. And when you were a kid, you looked at a shape and you said, okay, I've got this triangle here. What's one thing that I can do to it? Well, I could slide it around and slide it over here. And no matter where I slide it around, it's always the same shape and size. So as a kid, you called that a slide. Well, now you're a grown-up, sophisticated geometry student. So the mathematical term for that, which is what we will be using from now on, so the mathematical term for that is a translation. Okay, so I just took my triangle and I translated it, and I translated it again, and I translated it again. We're not going to call it a slide, we're going to call it a translation. Okay, so a translation is an isometry because it preserves the shape and size. Nothing about my triangle changed. Okay, another thing that you might do is you might flip it. So I can take my triangle and I can flip it over. and then I could flip it again, and then I could flip it again, and I could flip it again, and no matter how many times I flip it, it's still the same size and shape, so it's an isometry. Okay, well, the mathematical term for that is a reflection. Okay, so we will be using the term reflection because we are mathematically sophisticated students. Okay, the other thing that you could do is you could turn it. So I have my triangle and I could turn it like this, or I could turn it like that, or I could take it and turn it this way. So I'm just turning it, okay, and it's still the same size and shape. It's an isometry. Okay, as a mathematical term, that is called a rotation. Okay, so these are the isometries that we are interested in: translations, reflections, rotations. Okay, so you should have a worksheet. Okay, and we're going to go through and try to see if we can figure out which of the isometries, translation, reflection, or rotation, occurred to transform each of these shapes from an image to a pre-image. Now, when you look at these two shapes, you might ask, well, how can I tell which one is the image and which one is the pre-image? Okay, so the standard notation is that if you look at this, we've got, this is an M. It's kind of hard to see on my camera, but this is an M and it's got a little mark up here. That's called a prime. So the M prime, so M is first, M prime is what comes later. So this right here is the pre-image, and it got turned into the image because you can see the little primes, the primes. Okay, over here, okay, this one doesn't have primes. This is the pre-image. This one has the primes. So that is the image. So when you go through and look at all of them, just look for the primes. The primes will show you the image. If there's no primes, that will be the pre-image. Okay, so looking at this one, what happened here? Hopefully you're saying, oh, that was a translation. All we did is we took this and we moved it this way, right? Okay, this one is a translation. Going on to this one, here is our pre-image. What did we have to do to get the image? We couldn't just like translate it, right? It won't look the same. Okay, we have to take it and we had to flip it over. What's a flip? That's called a reflection. Okay, so this one is a reflection. Okay, this one, this has no primes. This is the pre-image, and then something happened to get it over here. Hopefully you can see you took this, and if we kind of rotated it around this way, it would land on top of this one. Okay, so this is a rotation. Okay, this next one, no primes. This is the pre-image. This is the image. What did we have to do to get from here to here? Just kind of translating it isn't going to make it look like that, right? And flipping it isn't really either. We'd have to take this and we'd have to turn it around. Okay, so that turn is called a rotation. It's a rotation. Okay, hopefully this one is pretty easy. You can see we just took this one and we slid it over here. Slide dial, that's called a translation. This is a translation. Okay, this next one is a little bit tricky. So you might look at this and be tempted to say, well, this is a translation. I just took this and slid it over. But you need to pay very, very careful attention. Or sorry, this is the pre-image with no, okay, you may have thought they just slid it this way. But be careful, if I slide it this way, the K would have to be over here and the L would have to be here. These seem to be out of order. Similarly, if I just slid it this way, the N would be over here and the M would be over here. So on further inspection, you can see, that's actually not a translation, because we are not going to end up with the vertices in the same order. Okay. Instead, what happened is we took and we flipped it over. We took this and we flipped it over. And when we did that, imagine, if I did that and I flipped it over this way, then K would fall on top of K, L would fall on top of L, N would fall on top of N prime, M would fall on top of M prime. So this is really a reflection. Okay, number 7. This one is also a little bit tricky. Okay, so when you look at that, you might look at that and think, oh, they just took it and kind of turned it around. It's a rotation. I kind of made myself a little one so we could look at this and see. So notice I have my W, my V, my U on there. So if I just took this and turned it like this, notice it doesn't work. Okay, because U is on this original triangle, but it says W prime here. This is T, but it says S prime. This is S, but it says T prime. This is W, but it says, clearly it's not a rotation. That is not what happened. Okay, so we did not do a rotation. Okay, in fact, what happened instead is there's a line right here, and we took it and we flipped it over like this. And now when we flip it over, you can see that a W is by W prime, S is by S prime, T is by T prime, U is by U prime, V is by V prime. So this one is actually a reflection. Okay. This one is probably a little bit easier to see. This one, you can actually take this and turn it or rotate it. This is a rotation. Okay, and then this one, okay, this H goes to, sorry, I guess it was backwards. H goes to H prime, D goes to D prime. So this one is a translation. Okay, so those are our different kinds of isometries. Now, when we're particularly interested in lesson 71, we're going to talk about translations and talk more specific, how you can specifically be more specific about describing a translation. Okay, so let's say that you had, a triangle and you put it on a plane and you wanted to talk about doing a translation. Okay, so you could do a translation like up 2 units. Okay, or you could go left 3 units, or you could go down 5 units, 1, 2, 3, 4, 5, or you could go right 4 units, 1, 2, 3, 4. Okay, you can go up, down, left, right, but sometimes you want to go both. Maybe you want to go up 3 and left 2. So you want to go up 3 and left 2 and move it over there. Okay, so how could I describe, besides just saying things in words, what might I do in order to describe a translation? Okay, so there's a couple of different ways you can describe a translation. So one of them is to use a vector. So we can use a vector to describe a translation. Okay, so for example, let's say I have my triangle and it starts at this position. Let me mark its vertices here, here, and here. And I want to move it, let's say, down 3 and to the right 1. Okay, so I want to go, if I would go to this vertex, I want to go down 3 and to the right 1. Okay, it would be moving along this vector that has a vertical displacement of 3 and a horizontal displacement of 1. Well, if I want everything this to be an isometry, each one of these is going to have to move along that same vector. So C is also going to have to go down 3 and over 1. And B is also going to have to go down 3 and over 1, right? So if I move it along that vector, you can see everything is moving, then my new position will be here, here, and here. So you can see that my initial triangle right here was made up by the initial points on the vectors. This is my pre-image. And then after it moved, okay, my image, so this was my original A, B, C, and my new image was A prime, B prime, C prime. Okay, and you can see that that same vector was used. So we would say, okay, now this vector, of course, with vectors, we go with horizontal displacement first. So this would be a translation along the vector. Okay, horizontal component was +1 and the vertical component was -3. Okay. All right, so that is one way that we can describe a translation. The other way that we can describe a translation is to use what's called mapping notation. So we can use mapping notation to describe a translation. Okay, so mapping notation has this format. It has T for transformation, and then we describe the transformation. We put a general point, xy. This is just an arbitrary xy. This represents a point, an arbitrary point on the pre-image. And then we draw a little arrow to show that that point is being transformed. And then over here, we describe how we're going to get the point on the image. Okay. Oops, this is only supposed to be 1A. Okay. And so there'll be some rule about how we get the X and a rule about how we get the Y. Okay. So, for example, let's say we had a general point XY. Okay, think about this. Well, what happened to every single X coordinate? Here, the X coordinate was 3, and it turned into 4. Here, the X coordinate was 4, 5, 6, 7, and it turned into 8. Here, it was 7, and it turned into 8. Okay, so when we went right 1, what we did is we added 1 to the X coordinate. So we would, our rule here could be add 1 to the X coordinate. Okay. Notice here, what did we do to the Y coordinate? Well, the Y coordinate started here and it went down 3. It started here, it went down 3. So how do we get the new Y coordinate? We take Y and we subtract 3 from it. Okay, so notice, okay, here, this 1 and this -3 are kind of helping us make a rule for this, the mapping notation. So this is just as you take an, so if I were to take the point, for example, here's the point 3, 1, 2, 3, 4, 5, 6. Okay, so this is saying, all right, well, when X is 3 and Y is 6, then in my pre-image, that's going to turn into X, which is 3 plus 1, which is 4. And then 6 here, so 6 minus 3 is 3. So it's saying that the point 3, 6 in the pre-image will become the point 4, 3. So that's my 4, 3 in the image. Okay. So hopefully that notation makes sense. All right, so let's do a couple of examples and we'll call it a day. So on page 474, we've got a couple of problems that we're going to try. So we've got a triangle. It's got vertices 2, 5. That's K. L is 111. M is 5, 7. And then we want to find the image of that triangle after the translation given by this rule for the mapping notation. We want to show the pre-image and the image on the same coordinate grid. Okay, so we should be able to just figure out. All right, so we started with K, which was 2, 5. And after it goes through this mapping, this is going to become K prime. And our rule says that we're going to take the X value, in this case is 2, and we're going to subtract 2 from it. Okay, so 2 minus 2, that's 0. And then to find the Y value, we'll take the Y value, which is 5, and add 1 to it. So 5 plus 1, that's 6. So our K prime should be 0, 6. Okay, and then we do the same thing with L. So L was 111. So L prime, well, we take the X value, we subtract 2 from it. 1 minus 2 is -1. And then we take the Y value, 11, and add 1 to it. 11 plus 1 is 12. So L prime should be -112. And then M is 5, 7. M prime. Okay, we're going to subtract 2 from the X coordinate. 5 minus 2 is 3. Add 1 to the Y coordinate. 7 plus 1 is 8. So those should be our image coordinates. Okay, now it asks us to show the pre-image and the image on the same coordinate grid. So I went ahead and I did the original KLM. And now let's graph our points that we calculated on this same grid. Okay, so K was 2, 5 there. K prime is going to be 0, 6. Here's K prime. L was 111. That's this one. L prime is -1, 12. So -1, 12 is here. This is L prime. And then M was 5, 7. That's this point. And M prime is 3, 8. So 3, 8 is here. Okay. And then when we sketch that triangle, it should be exactly the same shape and the same size as the original because translation is an isometry. And then if we wanted to, we could describe this as a vector, horizontal -2, vertical 1, which makes sense, right? We subtracted 2 from X and added 1 to Y. So we see that relationship between the mapping notation and the translation vector. I'll just go ahead and write that on there. So the translation vector is going to be -2. That's what happened in the X direction, the horizontal direction, and +1. That's what happened in the vertical Y direction. Okay. All right, the next one. Find the coordinates of the vertices of the image of the parallelogram ABCD after the translation by the vector 3, 1. What parallelogram are they talking about? Okay, in your book I've drawn it here so that we can see it. Okay, so the vertices, I've graphed them here, and we want to do the translation vector 3, 1. Okay, and so that would be a horizontal displacement of +3. So let's imagine I'm starting at C. I would go horizontally +3 and then vertically +1. So this is my translation vector right here. I have to do that from B as well. +3 horizontal, +1 vertical. A is going to go 3 and 1. D is going to go 3 and 1. Okay, and so my new parallelogram will be at the end here. This will be my A prime, this will be my D prime, my C prime, and my B prime. It should be exactly the same size and shape as the original, okay, but it got moved over horizontally 3 and vertically +1. Now if we wanted to write the transformation mapping for this one, okay, this would be the mapping. Okay, it took an arbitrary point, x, y, like A or B or C or D. And then what did it do? It added 3 to the, moved it over 3 horizontally in the x direction. And then it added 1 to the y. It went up 1 in the y direction. Okay, so those are the 2 different notations for doing translations. All right. And I will see you guys next week.